The C programming language is a powerful tool for telling computers what to do. It was created in the early 1970s. Dennis Ritchie developed C at Bell Labs, and he worked alongside Ken Thompson. C was initially designed to help write the Unix operating system. This close connection to system development made C very efficient. It provides a good balance between high-level readability and low-level control. Many programmers find this balance very useful for a wide range of tasks. Understanding C can open many doors in the world of software development. C is important for several key reasons. First, it is a foundational language. Many other popular programming languages like C++, Java, C#, and Python have borrowed concepts from C. Learning C can therefore make it easier to understand these other languages later. It teaches you fundamental programming principles very clearly. Second, C is known for its performance. Programs written in C can run very fast. They can also manage computer memory very directly. This makes C suitable for tasks where speed and efficiency are critical for success. The influence of C extends far beyond its initial use. It has become a standard in many areas of computing. Because it is relatively small and can interact closely with hardware, it is often used for system programming. This includes writing operating systems and device drivers. Its efficiency also makes it a good choice for embedded systems. These are small computers inside larger devices like microwaves or cars. The principles you learn with C are timeless in computer science. They will serve you well throughout your programming career in many different fields. Furthermore, C gives programmers a great deal of control. You can manage memory directly and work close to the computer's hardware. This level of control is not always available in higher-level languages. While this power comes with responsibility, it allows for highly optimized programs. For beginners, C can seem challenging. However, mastering its concepts provides a deep understanding of how computers actually work. This fundamental knowledge is invaluable. It helps you become a more effective and knowledgeable programmer, regardless of the specific languages you use in the future. Understanding how C code works involves a few key steps. You begin by writing your program in a human-readable text file. This file is called the source code. The source code contains instructions written according to the rules of the C language. These instructions tell the computer what tasks to perform. For example, you might write code to add 2 numbers or to display a message on the screen. This source code, however, is not something the computer's processor can understand directly. It needs to be translated first. The translation process is handled by a special program called a compiler. The C compiler reads your source code. It checks for any errors in your C syntax. If it finds errors, it will report them to you. You must fix these errors before the process can continue. If the code is correct, the compiler translates it. It converts your C instructions into machine code. Machine code consists of binary instructions, zeros, and ones. These are the native language of the computer's central processing unit, or CPU. This step is crucial for execution. Once the compiler has generated machine code, it is often stored in an intermediate file called an object file. Sometimes a program is made up of several source code files. Each file can be compiled into its own object file. Another program called a linker then takes these object files. It combines them with any necessary library code. Libraries are collections of pre-written code that provide common functionalities. The linker resolves references between different code parts and produces a single executable file. This file is the complete program, ready to run. Finally, to run your C program, you execute this executable file. When you run it, the operating system loads the program into the computer's memory. The CPU then reads the machine code instructions from memory and executes them one by one. This is how your C program performs the tasks you defined in your source code. From writing simple text to seeing your program in action, it's a journey from human ideas to machine execution. This process, while detailed, becomes very familiar as you gain experience with C programming and its tools. To start writing and running C programs, you need a suitable programming environment. This environment typically consists of 2 main components. First, you need a text editor to write your C source code. This can be a simple editor like Notepad on Windows, TextEdit on macOS, or more advanced code editors. Many programmers prefer editors designed for coding like Visual Studio Code, Sublime Text, or Atom. These editors offer features like syntax highlighting, which makes your code easier to read. Choose an editor you find comfortable to use. The second essential component is a C compiler. The compiler, as discussed earlier, translates your C source code into machine code. A very popular and widely used C compiler is GCC, the GNU Compiler Collection. GCC is free, open source, and available for most operating systems, including Windows, macOS, and Linux. For Windows users, MinGW, which stands for Minimalist GNU for Windows, provides GCC. On macOS, you can install GCC through Xcode command line tools. Linux distributions often come with GCC pre-installed or easily installable through their package managers. Many developers choose to use an integrated development environment, or IDE. An IDE combines a text editor, a compiler, a debugger, and other helpful tools into a single application. Popular IDEs for C programming include CodeBlocks, Eclipse CDT, and Cleon. Visual Studio, not Visual Studio Code, is also a powerful IDE for C development on Windows. IDEs can simplify the process of writing, compiling, and debugging C programs. They often provide project management features which are useful for larger programs. For beginners, an IDE can make getting started a bit easier. Once you have your text editor and compiler or an IDE, you are ready. You will write your C code in the editor. Then, you will use the compiler to turn it into an executable program. If you are not using an IDE, you will typically compile your code using commands in a terminal or command prompt window. For example, with GCC you might use a command like gcc myprogram.c-o myprogram. This command tells GCC to compile myprogram.c and create an executable file named myprogram. Learning these basic commands is part of the C programming journey. C programs work with data. Data comes in different forms called data types. Common basic data types in C include int for integers like whole numbers such as 5 or -10. Another is float for floating point numbers, which are numbers with a decimal point like 3.14 or -0.5. The char data type is used for single characters, like the letter A, Z, or the character 7. These fundamental types allow you to represent different kinds of information in your programs. Choosing the correct data type is important for memory efficiency and program correctness. C also supports modifiers like short, long, signed, and unsigned to alter these basic types. To store and manage data in your C programs, you use variables. A variable is a named location in memory that holds a value of a specific data type. Before you can use a variable, you must declare it. Declaring a variable means specifying its data type and its name. For example, int age declares an integer variable named age. You can then assign a value to this variable, like age equals 30. Variable names must follow certain rules. They can contain letters, digits, and underscores, but they cannot start with a digit. Good variable names make your code easier to understand. Functions are fundamental building blocks in C. A function is a named block of code that performs a specific task. Programs are often organized into many functions. This makes the code modular, easier to manage, and reusable. Every C program must have at least one function called main. The main function is special. It is where the program execution begins. A function can take inputs, called parameters or arguments. It can also return a value to the part of the code that called it. For example, a function might take two integers as input and return their sum. Defining a function involves specifying its return type, its name, and its parameters, if any. The code that the function executes is enclosed in curly braces. For instance, a simple function to add two integers might look like this: int add open parenthesis int a, int b close parenthesis open curly brace, return a plus b semicolon close curly brace. Here int is the return type, add is the function name, and int a and int b are the parameters. The return a plus b statement calculates the sum and sends it back. Using functions helps break down complex problems into smaller, more manageable pieces, which is a core principle of good programming. Alright, so C programs often need to communicate with the user or display results. This is done using input and output operations. The standard C library provides functions for this. For output, the function is commonly used. It allows you to print text and variable values to the console. For example, prints the message "Hello World" followed by a new line character. To print a variable's value, you use format specifiers like to print an integer variable. This is a fundamental way your program can show information. For input, the function is often used. It reads data entered by the user from the keyboard. Similar to, uses format specifiers to determine the type of data to read. For example, would attempt to read an integer from the user and store it in the variable. The ampersand before the variable name is important. It provides the memory address of the variable so knows where to store the input. Handling input carefully is crucial, as incorrect input can lead to program errors or unexpected behavior. Loops allow you to repeat a block of code multiple times. C provides several types of loops. The loop is often used when you know how many times you want to repeat. For example, we'll print numbers from 0 to 4. The loop repeats a block of code as long as a certain condition is true. For instance, another loop is the loop, which is similar to but guarantees the code block executes at least once. Conditional statements allow your program to make decisions. They execute different blocks of code based on whether a condition is true or false. The most common conditional statement is, for example, you can add an block to execute code if the condition is false. For multiple conditions, you can use these control flow structures. Input and output, loops and conditionals are, honestly, essential for writing programs that can perform complex tasks and respond to different situations. Let's create a very simple C program. This program will display the message, "Hello World," on the screen. You know, it's a traditional first program for beginners in many programming languages. We'll go through each part of the code step by step, and this will help you understand the basic structure of a C program. Even this small program introduces several important concepts. So, open your text editor or IDE and create a new file. Save it with the extension, for example. This extension tells the compiler that it is a C source code file. Now type the following code into your file hash: include int main, printf hello world n, return 0. The first line is a preprocessor directive. It tells the compiler to include the contents of the file. This file is a standard header file, and it contains declarations for standard input and output functions such as, we need this line to use the function later in our program. Header files provide information about functions that are available for use. The next part is, this defines the function. As mentioned before, as a special function, it's the entry point of every C program. Execution of your program begins here. The before indicates that this function will return an integer value. The parentheses after indicate that it is a function. They can also hold parameters if the function needs any input. The code for the function is enclosed within the curly braces, and these braces define the beginning and end of the function's body. Inside the function we have two statements. The first is, this line calls the function. It prints the string hello world to the console. At the end of the string is a special character. It represents a new line. This means that after printing the message, the cursor will move to the next line. The second statement is, this line ends the function. It returns the integer value 0 to the operating system. A return value of 0 typically indicates that the program executed successfully. Other values might indicate an error. Despite its age, C remains a highly relevant and widely used programming language in 2025. One of its most significant uses is in system programming. The core of many popular operating systems such as Windows, Linux, and macOS contains a substantial amount of C code. This is because C provides low-level access to memory and hardware. It allows developers to write efficient code for managing system resources. Device drivers, which enable the operating system to communicate with hardware components like printers and graphics cards, are also frequently written in C. Embedded systems are another major domain where C programming thrives. Embedded systems are specialized computer systems found in a vast array of devices. These include automotive control systems, medical devices, industrial controllers, and consumer electronics like smartwatches and home appliances. C is favored for embedded development due to its small footprint. It requires minimal runtime support, and it also offers direct hardware manipulation capabilities. This makes it ideal for resource-constrained environments where performance and efficiency are really paramount for correct operation. The world of high-performance computing also relies heavily on C. Scientific simulations, financial modeling, and large-scale data analysis often require immense computational power. C's ability to produce highly optimized and fast-executing code makes it a preferred choice for these demanding applications. Many libraries used for numerical computation and parallel processing are implemented in C game development, particularly game engines, also utilizes C and its close relative C++. The performance-critical parts of game engines often use C to achieve the necessary speed for real-time graphics and physics. Furthermore, C is often used to create other programming languages and tools. Compilers, interpreters, and debuggers for many languages are themselves written in C. This is a testament to C's efficiency and its capability to manage complex tasks. Even in the age of newer, higher-level languages, C continues to be the backbone for much of the software infrastructure we use daily. Its enduring presence highlights its power, flexibility, and the fundamental control it offers to programmers who need to work close to the hardware or demand maximum performance from their software. Learning C programming can be a rewarding experience. To make progress, consistent practice is very important. Try to write small C programs every day, or as regularly as you can. Start with simple exercises. For example, write programs to perform basic arithmetic operations, or try programs that manipulate strings or work with arrays. The more you code, the more comfortable you will become with C syntax and concepts. Don't just read about programming, actively do it. This hands-on experience is crucial for building your skills. Reading code written by others is also a very effective way to learn. Look for C projects on platforms like GitHub. Start with small, well-written examples. Try to understand how they work line by line. This can expose you to new programming techniques and best practices. Pay attention to how experienced programmers structure their code, name variables, and use functions. You might also find it helpful to modify existing code. Try adding new features or changing its behavior. This can be a great way to experiment and deepen your understanding of the code. Don't be afraid to make mistakes. Errors and debugging are a normal part of programming. When your program doesn't work as expected, see it as a learning opportunity. Carefully read any error messages from the compiler. Learn to use a debugger. A debugger is a tool that allows you to step through your code line by line. You can inspect variable values and understand the program's flow. This helps pinpoint where things are going wrong. Patience and persistence are key when you are trying to find and fix bugs in your programs. As you gain confidence, start working on small projects that interest you. This could be a simple calculator, a text-based game, or a utility to manage files. Working on projects helps you apply what you've learned in a more comprehensive way. It also gives you a sense of accomplishment. Break down larger projects into smaller, manageable tasks. Celebrate small victories along the way. Remember that learning to program well takes time and effort. Be patient with yourself and enjoy the process of discovery and creation that programming offers. Your journey with C programming does not end with the basics. There is always more to learn and explore in this powerful language. As you become more comfortable, consider delving into more advanced topics. These include pointers, which are a core feature of C, giving direct memory access. Understanding memory management, dynamic memory allocation with, and is also crucial for writing robust C programs. Exploring complex data structures like linked lists, trees, and graphs will further enhance your programming skills and problem-solving abilities significantly. There are many excellent resources available to help you continue learning C. Classic books, such as The C Programming Language by Kernighan and Ritchie, remain invaluable references. Many online platforms offer C programming courses, tutorials, and coding challenges. Websites like Geeks4Geeks, Stack Overflow, and various programming forums can provide answers to your questions. They also offer a community where you can interact with other learners and experienced developers. Engaging with these resources can provide structured learning paths and support when you encounter difficulties or new concepts. Joining programming communities can be very beneficial. Whether online or in local meetups, connecting with other C programmers allows you to share knowledge. You can collaborate on projects and get inspiration. Explaining concepts to others or helping them solve problems can also solidify your own understanding. Consider contributing to open-source C projects. This is a great way to learn from experienced developers. It also helps you build a portfolio of your work. Real-world project experience is highly valued and provides practical insights. Finally, the most important thing is to keep programming and building things. The more you apply your C knowledge to create software, the more proficient you will become. Set yourself new challenges. Explore different areas where C is used, such as system programming or embedded systems, if they interest you. The skills you develop by learning C are transferable to many other areas of technology and beyond. Embrace the continuous learning process. Enjoy the power and versatility that C programming offers to those who master its intricacies.